Hi, in this video we're going to work on dividing polynomials by polynomials. So this is pretty much long division, hence I'm just going to remind you of long division with numbers first, and then we're going to talk about polynomials. So let's look at this example. Now here we want to divide 125 by 8, and what we're going to do is we're going to ask how many 8s go into 1, which is 0. So we are going to expand to 12, and we're going to ask how many 8s go into 12. And yes, there is 1 8 going into 12, so that's going to be, okay, let's write this one down. 1 times 8, which is 8. So 12 minus 8 is 4, so we're subtracting the numbers, and at this point what you find here must be smaller than the divisor 8 in this case. Alright, that is very important, otherwise this means more 8s go into whatever number you're asking. Right, so your answer here is wrong. That's what it means. You have to make sure that this number here must be small. Right, so now I'm going to drop down 5. So that's a 45 now. In 45 we have 5 8s, so 5 8s go into 45, and 5 times 8 is 40. And then we take away again, 45 minus 40 will give me 5. And again, this number is smaller than 8, so I'm good. But you can see that there's no more numbers left that I can drop. Now, at this moment, in year 7, you'll learn to just put a 0, which is the decimal part here, because it is now 125.000 and so on. Just because you switch to decimal part, you keep on dividing until you find no remainder. Alright, but we're going to stop here, right? Because while dividing polynomials, we are not going to go on when we have a remainder. We just stop there. Alright, and that's going to be our answer. So for this one we can say 125 is 15 with remainder 5, right? So what we're going to do with polynomials is similar. Okay, so this is how we do the division. Now, before going on with the division, let's talk about the polynomials themselves. A polynomial is an algebraic expression with positive powers of the unknown, right? Now what happens is that if I write down x squared minus 5x plus 7, this is a polynomial, right? Because I have the powers 2, 1, and then here we have x to the power of 0, which we don't write at all, because any number to the power of 0 is 1, so it's just 7 itself as a constant, right? But you can see these digits for the powers are positive powers. So it is not only positive, actually I should add here that these are positive integer powers. Alright? This is very important, because if I was to write x to the power of 3 over 2 minus 7x to the power of 1 over 2 plus 5, and this is not a polynomial because of the powers. The powers are positive, but they're not integers, they're fractions. Okay, so this is not a polynomial. And there may be different unknowns, or the powers could be bigger. It doesn't matter, as long as they're positive integer powers, we're good. And the numbers in the front does not matter. The coefficients could be fractions or surds, it doesn't matter. So I can go like 3/5 of x to the power of 4 minus 7 over 12 x squared plus 100 over 14. I'm just making it up, right? So this is a polynomial. I don't care what the coefficients are. All I care is the powers. Are they positive? Yes. Are they integers? Yes. So these are polynomials. Now, if I have 3x, this is called as monomial, as mono being 1. So this is monomial, means one term, right? And if I have 4x squared minus 7, then this is called as binomial, by being 2, right? So this is 2 terms. So we're going to see this term again in a few chapters in binomial expansion, right? So it's about the expansion of two-term expressions, basically. So it's binomial. And then if we have 2x squared minus 3x plus 4, for example, this is called as a trinomial with 3 terms, right? It's 3 terms here. And as always, human beings get bored after 3, so the rest is called as polynomials, right? Because after 3 is many terms, so it's polynomials, all right? So these are polynomials with positive integer powers, right? Now, let's switch to division. Right. In this example, it says divide x cubed plus 2x squared minus 17x plus 6 by x minus 3. So let's put these numbers around. I prefer to write the expression first, like x cubed plus 2x squared minus 17x plus 6, and then I just draw this. So I can write here x minus 3. I think it's best if I move it here. Right, okay. Now let's start. I must get the first term here, which is x cubed. To get x cubed, I have to write here x squared, because what happens is I'm going to multiply x squared by this x minus 3 expression here. So what's going to happen is x squared times x is x cubed. X squared times minus 3 is minus 3x squared. Now, remember in long division we were always subtracting. So I want to keep on with subtraction. So I'll just change the signs. So it's going to be minus and this is going to be plus, so that when I add them, actually I'll be adding them, I'm going to get rid of x cubed, right? Or, well, if you'd like, you can just keep it like this. Put the minus sign here and say x cubed minus x cubed is, they cancel each other out. And then you can go like 2x minus 3. So this is 2x squared plus 3x squared. So you're going to end up with 5x squared. The signs are extremely important here. That is why I'd like to work with changing the signs. So what I do is I just change the signs so that it's going to be subtraction when I add them. So x cubed minus x cubed, these are gone, right? And then I'll have 2x squared plus 3x squared. I'll have 5x squared. And then I'll just drop everything here down beside 5x squared. So it's going to be 5x squared minus 17x plus 6. Next, I'm trying to get 5x squared here. So I'm going to go on with plus, because this is positive, 5x, because when I multiply 5x with x here, right, I'll get 5x squared. So that's what's going to happen. It's 5x squared when I multiply 5x and x, and then 5x times minus 3 is minus 15x. And then again, I'm going to change the signs. That's going to be minus, that's going to be plus. So these are gone when I add them. And minus 17 plus 15 makes minus 2x plus 6. Now, I must get minus 2x. For this, I have to multiply the expression by minus 2, because minus 2 times x is minus 2x. And minus 2 times minus 3 is plus 6. And here, if I change the signs, this is plus, this is minus, when I add them, these will cancel each other out, and I'm going to get a 0 as the remainder. This means x minus 3 divides this expression properly. So I can write, this is also very important, x cubed plus 2x squared minus 17x plus 6 is equal to x minus 3 times whatever I find here, x squared, x squared plus 5x minus 2. So I just started factorizing this cubic expression, right? I have a factor here and I have a trinomial here, which is a quadratic, and later on I could go on factorizing this if possible, of course, and then I could end up with 3 factors starting with x minus 3, right? That's how I can factorize a cubic expression. Let's see another example. So this one says find the remainder when this expression is divided by x minus 4. So basically I will start dividing, and when I end up, I'll end up with a number most probably as the remainder. So let's start. So first I'll try to get 2x cubed, so I'll multiply with 2x squared. 2x squared times x is 2x cubed. 2x squared times minus 4 is minus 8x squared. Changing the signs, I will add them up, getting, well, these are gone. Minus 5 plus 8 is going to be 3x squared, and I'll drop these beside. 16x plus 10, minus 16x plus 10. Then I'm going to go on with minus 16. No, sorry, that's the next step. I'll go with plus 3x. So if I multiply by 3x, I'll have 3x squared, and 3x times minus 4 is minus 12x. And if I change the signs, I'm going to get minus and plus here. If I add them, these will cancel each other out. Minus 16 plus 12 is minus 4x, and I drop 10 beside, plus 10. Now, I have to get minus 4x, so I will multiply by minus 4. Minus 4 times x is minus 4x. Minus 4 times minus 4 is plus 16. So if I change the signs, I'll have plus here, minus here. These are gone. 4x is simplified. 10 minus 16 will give me minus 6 as a remainder. So it says find the remainder. I found it. It's minus 6. So this is how I apply long division to polynomials. So the idea is you try to get these expressions, these terms one by writing an appropriate term here, because you're going to be multiplying it with whatever is here, right? And then you just carry on with the workout, right? Generally speaking, you will mostly have a binomial with the first degree, so it's going to be x minus 4, x plus 3. Sometimes you might see 2x minus 1 sort of expressions, but I don't think it's going to be something like x squared plus 7 or 7x, something like that. We won't be dividing polynomials by these expressions, but it could be something like this, right? But it's not hard, it's just long, and you have to be extremely careful with the signs so that you won't make any mistakes. Right. Thanks for watching.